This video shows the simulation of a pressure surge event using the Xpsim dynamic simulation. An oil transportation pipeline, 50 kilometers long, is considered. The pipeline diameter is 20 inches, 0.489 meters. The oil is defined using 35 chemical components, most hydrocarbons from methane to C20. The initial flow rate is set at 1,585 cubic meters per hour. The inlet pressure is 68 bar and the outlet pressure is around 30 bar. Heat transfer between the oil and the external ambient through the pipeline wall is considered. The sonic velocity of the oil is about 1050 meters per second. This value is calculated using the thermodynamic equation of state for each pipeline segment and each integration time step. The initial oil transport is simulated for a time interval of 30 minutes when, for emergency reasons, the outlet valve is closed in a 2 seconds interval. The Xpsim simulation application is started and the input file is open. The process flow diagram window shows the main pipeline TR line, with the feed and input lines which include 2 control valves. Let's have a look at the input statements. We ignore the general data. Passing to the petroleum data category, which shows the definition of 11 pseudo-components. The ChemComp statement defines the other 25 chemical components. The method statement defines the thermodynamic and transport property models required by the simulation. In the default data category, a number of materials are defined. A wall statement defines the layers forming the wall of the following pipeline. The feed stream S1 is defined by the molar fraction of 36 hydrocarbon components. Now the user quickly navigates through the other statements used to define the objects inserted in the PFD. A number of virtual instruments are inserted in the pipeline input. Pressure, temperature, and liquid velocity are measured at the inlet and outlet points, as well at 10, 20, 30, and 40 kilometers. On the valve CV1 controlling the outlet flow, an event is defined. The valve is closed 30 minutes after the simulation starts in a 2 seconds interval. In the solution data, the calc statement defines integration steps. The initial value is set at 0.1 seconds. The minimum value at 2 milliseconds. And the maximum value is 5 seconds. The time interval for trend values registration is 1 hour. With a sampling frequency of 1 second. The dynamic simulation is started and the plant view interface is created. The calculation stops after the initialization is completed. And after the first integration step. As the calculation goes on, the user can browse instrument values either in the bar or trend views. Instruments are collected in 6 groups. At the bottom of the view, the time step used by the integration algorithm, and the current speed ratio, that is the ratio between the simulation time interval and the actual clock time intervals, is shown. The event view provides information about the status of all the events defined by the user for the simulation. The pipeline view shows some of its internal data: elevation, pressure, and pipeline profiles. Let us resume registration of the simulation at minute 28, 2 minutes before the closing of the outlet valve. The simulation is frozen at 30 minutes, as defined in the input, but the user restarts it immediately. Valve closure is completed in 2 seconds and the instruments attached to the pipeline exit points signal the event. The event view shows valve closure as completed. After 20 seconds the pipeline's internal pressure shows a sharp increase at the exit and at 40 km. At 30 seconds after the valve closure the internal pipeline pressure is around 72 bar. The velocity and pressure graphs are shown as compressed since the trend time interval is set to 1 hour, but, being registered with a frequency of 1 second, the user will be able to plot the waves with fine detail. At 1 hour the simulation is frozen, and the user can realize that pressure oscillations are completed. The user has stopped the simulation and the plant view window has been closed. All the graphs generated during the simulation can be opened and browsed. The user can get a rapid overview of all the generated graphs of the 35 instruments defined. Now the graphs of the pressure at the pipeline inlet is located. By double-clicking on its line, each graph can be opened in a separate window. Now the pressure graph at the pipeline exit is located and opened. Using the P00 instrument graph as starting point, the PEXI pressure graph is embedded using one of the numerous customization functions. Now the time axis unit of measure is changed from seconds to minutes. Finally, the range of the x-axis is reduced from 1 hour interval to the interval 28 to 60 minutes. The new graph shows clearly the pressure oscillations at the inlet and outlet points. The maximum pressure value is reaching 96.07 bar. The graph can be saved as a JPEG image, ready to be included in engineering reports.